Where did it go? Your pen. Okay. Today we will start a new chapter. It's about the transport layer, right? I know that actually the previous chapter we still have 2 topics left, but that's 2 topics about the standard protocol that I will go back to that point when we do before we do the lab about it, okay? And today I have an economic meeting, so maybe we have to finish the class around at noon, okay? So before we go to about the transport layer, I think we should recall your knowledge about the data link. Physical we didn't talk about it much. We talked about data link and the network layer before, right? And the protocol model, right? This is the basic protocol model that you learned before, right? And also it's in your exam, okay? You know, this is the physical layer. This is the transmission media. This is a medium, right? And we talk about that actually the scope of each of layer, they have their own scope, right? Right, for the data link, it's between this node, any node, to the next node over the same link, right? What is this scope? What is the scope of this data link? And data link, the next link, it also do the same scope, right? What it is about the link and the the source node and the next node, right? Is node to node, right? And the next hop is also and you know that this is a logical connection, right? This is a logical connection, but the scope of the logical connection or the data link is just a node to node. And what is the logical link for the network layer? The network layer, you already learned all, right? What they do, they forward, they packetize, they forward, then they routing, right? Select the path from node to node or from source to the destination. Which one? Network layer, they select the path from node to node or from the source to the destination. Yes, it's source to the destination, right? So the scope of the logical connection is host to host, right? Whatever the IP layer, right? I have to specific now, right? IP also a network layer, LIP also a network layer, OSPF also is network layer, okay? ICMP also a network layer. For the IP, what they do routing or they do forwarding. Which one? Which one? What is the main function of IP? Actually, the main function of IP is to packetize, right? It's packetize, okay, including fragmentation and also forwarding or routing. Which one? Forwarding or routing? Forwarding, yes. Right? Who do the routing? Who do the routing? Who do the routing? Previous chapter. What is the name of that chapter? It's a unicast routing protocol, right? It's a routing protocol. What is the kind of routing protocol? Actually, we learn about this stand vector, right? And the standard is lib, and also link state. The standard is, what is the standard for the link state routing protocol? What is the standard protocol for that use the link state algorithm? Which one? OSPF. These two, you will do the lab later. Okay? Now, you have a physical layer, data link layer, network layer. You can list the destination, right? The destination host. That is the real destination or not? Who generated data? Who generated information or data? Who is the real source in this stack of protocol? Who is the originator? The application. Right? The application run on your computer, whatever. Right? And the application, when in a running state, what is that? What is the programming in the running state we call? It's called, when you have a program, when you execute it, it changes to the running state. Right? We call it it's a running program, right? Actually, we call it a process, right? In the operating system. This is the real originator and also the real destination, right? Except user, right? We don't cover it. Actually, when we talk about this, I have to write over this. Because actually, when we talk about the application layer on networking, it's not this. It's not the application process, but it's about the application protocol, right? Like, but we usually when you learn about the network, we ignore about this, okay? But we will think about what is the kind of application. This is a network application, like HTTP, right? Or SMTP, right? This is standard for your web application. So when you build the application, right? Mostly you have two sides, server side and the client side. And the server and the client based on this application protocol to build a communication, right? Both the client and server use the same application protocol. This is your application layer. Actually, this one, this is also a process. This is also a process. But some of them is the process in the foreground. Actually, most of them is a process in the background. Like when you use the HTTP for servers, you didn't execute it by yourself, right? When you start up the server will have some script automate running this kind of application protocol. And this, on the server side, most of them running in the background. That means your user interface never interact with them. Right? Usually, user just interact to the foreground application. Right? You interact to your web browser, but you seldom interact to your web server like Apache. No, because the Apache will run in the background state. In the Unix or Linux operating system, we call it a daemon. Right? This kind is a daemon. Right? Daemon is the background process. This is not. You can take a note. Right? I didn't go to the detail about all of this because this is not exactly the network. Right? It's in the boundary between the network and operating system. But I think it can help you to understand about the application protocol. Oh, okay. Go back to our network layer. Sorry, application layer. So it means that our application layer is this kind, right? Not the IE, not Firefox, not the on the Mac what you use for the browser. What? What? Sub browser. Okay, I never use it. Okay, not that. No, not Apache also. Right? Not the internet server from Windows Server. No, right? This is the application layer in our network stack, right? So you also have this, some other application layer also, like SMNP or DNS. Right? All of this is the application layer, network application layer. Right? So, from our networking view, from the view of networking, this is the originate of data and the real destination of data. Right? So it means that when your packet arrives at some host by a network layer, your packet didn't deliver to the real destination. Right? Your packet just reached the host, but didn't deliver to the real destination. So that's why you need the other one, right? That allow you to list this this is a process, right? But if the process in the background, we call it a daemon. Okay? So how to list this process? You use this one, right? Or this one is the transport layer. Right. So for the transport layer, you also have, sorry, I have to remove this. Actually, I have to write on here, right? Host to host, and this is process to process, right? Because when you look at this transport layer, you will see this one or you see this one, right? And transport layer will identify the process, the real destination process for you. Right? So that's why the logical connection of the transport layer, actually the length of the logical connection is a process to process. Right? So I can replace this application layer, right? By a process. But I mean that the process is the process for the network layer. Sorry, application layer, right? So now, when we learn about the transport layer, right? We're gonna learn about how the protocol manages the packets to list the process. Right? This is the real destination and real source. Right? The ultimate source and ultimate destination of the packet. Okay? This is the whole picture of the transport layer that we're gonna learn in the detail, right? So if you understand this, I don't have to give you much lecture, right? You already understand why is the process-to-process communication between two application layers, right? Because the application layer, when you in the running state, right? Application layer is SMTP or HTTP or DNS or SMMP, right? And when work in the running state, we call it a process. Okay? And the transport layer functionality is to deliver the packet to the correct process and also get from the correct process. Okay? And why we call it a logical connection, right? You already see this, right? We already learned all about this at the beginning of term, right? The network model, right? In the network model, you know that this logical connection you can imagine, right? And the benefit of this imagine is that when you learn the protocol, especially in the upper layer protocol, right? The transport layer, right? Or the process of application layer can imagine, and also the meaning of the imagine is that this application process support your implementer for this application process. Suppose you write the code for the application process. You can do it by thinking that you have a logical connection over this. Okay. You can transparent all the lower layer from your view. This is the concept of modularity in a network. Right? Concept of layer in the network. Okay? Actually, this is also the same, right? The transport, right? Actually, if you look at the network layer or data link layer or physical layer, they pass many things, right? Usually, most of them is a kind of what kind of node? What kind of node that in the intermediate between these two hosts? This is the transit node, right? All of these is the transit node, right? Only 2n is a host, and only 2n has a transport layer, right? Need the transport layer. Over the transit node, right? All the transit nodes don't need a transport layer, right? Because they don't hold the process at the end. Okay? Right? So same concept, right? So that's why you can imagine this logical connection. Actually, it's already in your exam, right? But at that time, you didn't learn about the detail about transport. You just only learn about the concept. Okay? So, what kind of the transit node? Right? It can be the LAN switch or WAN switch or the router. Okay? Or layer 3 switch. The same. The same concept at the other layer. You see, the transport layer sits between network and application, right? So what they should do? Right? Actually, if you understand well about the network model, right? You already understand all. Right? The upper layer must get the service from the lower layer, right? And the lower layer must provide the service to the upper layer. So that means the transport layer between the transport layer and network layer, who get the service? Who get the service? Who is the upper layer? Who is the upper layer? Between transport and network. Why? Definitely is transport. Right? So the transport gets the service from network layer. And between the transport and application, who is a lower layer? Transport. So the transport provides the service to application layer. Yes. So all about this. So that's why I mentioned you about that. If you can do the midterm well, you already almost get all. Right? Because the midterm is the fundamental for everything. But if you cannot do it well, we will repeat it again here, right? But every time you have to recall about before the midterm. Right? This I already mentioned you at the beginning, right? If you look at this, right? This is the process, right? Actually, the process can be on the client side or the server side, right? It's about the application architecture, right? Our application architecture now mostly is the client server model, right? Whatever you have other model, like a peer-to-peer application, right? Is a network application, right? Mainly we have the client server model and the peer-to-peer model, right? Anyway, whatever is a process in the application layer. Right? And the domain of the network layer, what is? It's a host to host. Right? Before this, I didn't call it a domain, I call it a scope. It's the same thing. Right? The domain of the network layer is a host to host. And the domain of the transport layer is a process to process. Right? At the middle is a transit node. Right? You have a lot of transit nodes, but you don't have to care, right? Because based on the transport layer, you have a logical connection. Right? And the logical connection is a process to process. Provide a process connection for you. Okay, we will go to the detail. The question is how to identify the process. How the transport layer identify the process. Right? Actually, you already learn all. Right? But you learn in the concept. Right? At the beginning of term, we talk about the address. Right? And the address, I told you before that the address actually we have address in the horizontal. Remember? Address in the horizontal. Right? What does it mean, address in the horizontal? Here. Right? The address that you to identify nodes or address that you to identify hosts. Right? They go on the horizontal way. Right? They use to identify different stack of the protocol. Right? Different stack is mean different node, different hosts. Okay? And we also need the other kind of address. Is the address in the vertical. Right? Vertical of stack, what does it mean? It means in the same stack. Right? We need it when what? When one layer have to support multiple upper layer, right? That is the concept of multiplexing and demultiplexing in your midterm exam also, right? That's why I ask you to do this. Right? In the midterm, you just draw this figure. This is the concept of multiplexing and demultiplexing. And also, actually, in your book, you just open to correct page, you get it. But you have to understand what I mean. Okay? So now, I already give you the answer for your midterm exam also. But Ukit told me that he is really surprised that this question really little people can do. I don't know why, but this is very easy question about this all of picture. In the exam, I just in case one or two more note, one or two more transit note in the picture. I ask you to draw this and this. Everything in the books. But you cannot just cut and paste. You have to understand. Okay? The concept of the multiplexing or demultiplexing, right, is already here. When we call it a multiplexing? When we call it a multiplexing? When? When we call it a multiplexing? Can you do this? This question in your midterm? And you're not sure? What is your name? I will check your book, answer book. If you cannot give me answer, I will cut it off. Here, who is the top 10 rank? Who in the top 10 ranking? You? Okay, give me an answer. This is the multiplexing and demultiplexing concept, right? When we do the multiplexing, the picture is the same, right? My question is when, which condition it do multiplexing? Okay, you answer me two questions at the same time. Okay, good. Right? When to do the sending? Right? Because when I told you that multiplexing and demultiplexing, you need it because one layer, this is transport layer, right? One layer serves to multiple upper layer, right? And if this one is the sender, right? This transport get the item from multiple entity, right? Multiple application or multiple process. So they do multiplexing, right? At the receiver side, transport get many items, any package, right? And they have to split and send to the correct entity, correct process. They do demultiplexing, right? So you don't have to, I don't have to explain anymore, right? But only that, the address, the vertical address that I mentioned before. Now it's not a MAC address, it's not a IP address, but it's this address or this identifier we call is the port number. And also the port number are separate between the UTP and TCP port. Right? As I can remember, it's a 16-bit port number. Right? So it means that you have allow 64K, right? That's 64K port number available for you. So now every process on top, or you can say every application, right? But when I told you, I said I call it the application. Sometimes you confuse. You will think about the browser or your user application. No, right? It's the network application. It's an application layer of our network stack, right? And run on the computer as a process, right? Every process must have the unique port number, right? And then in this case it's the client server model, right? It's the client server application model, right? Mostly our clients, if you notice, but it's very hard, I know, very hard for you to notice this, that you must have the network analyzer to tap. And actually, you know, your simulator can do all. If you want to see, your simulator can do all. And okay, I forget to inform you, right? We already moved the simulator to the main computer system. So I hope it all fine. Okay? It consumes a lot of resource in our school computer system. Right? So use it. This is your opportunity. Okay? So tomorrow I can book the computer room for you. So please bring your laptop here. Okay? I cannot book the computer room for all you. Right? So everyone bring the laptop here. Okay? This is for do the multiplexing and demultiplexing. And also if you look at the client size, mostly it's a big number. Right? Because they will reserve the length at the end of address space for the client side. That is a temporary port number, right? It's a ephemeral number. It's a temporary. And for the most of the server side port number is a small number, right? Because they will reserve at the beginning of address space for specific application. But actually most of them are the same application, right? But this is the application in the server side, and this is the application in the client side. Let's say suppose this is about the web application. This also the HTTP PHP application layer. This also the HTTP application layer. But this is HTTP on server side, and that is the HTTP on client side. Because when you talk about the client server model, your HTTP on both sides are not equal. It's a symmetric model. Right? It's not equal. If your application is peer-to-peer, the network application on both sides are equivalent. That is a peer-to-peer model. Okay? So that's why it's different. Okay? It's a 16-bit length that correct. Any question about this? So the transport layer will identify the correct process, right? Actually the destination process, right? The designated process for you by using the port number. But if you look at this, what does it mean? What it means that your package must already list the correct host also. Right? So in terms of process, it means that the process must be, the process can identify the correct process, the correct destination process when they can identify both host and process number. Right? They need both. Right? The package must go to the correct host first and go to the transport layer, right? Oh. And we need both the source port and the destination port. Right? When you do the response, the same, right? If you want to do the response, right? This source, this one, okay. This source will turn to be destination, right? This is the concept of the address in two-way communication, right? You need both the source and the destination, right? And when you do the reply or response, you sweep the address. Okay? And as I mentioned you, only the port number is not enough. Right? Because we can use the port number to identify you go for sleep. If you use only the port number, it means that the packet must list the destination host before, right? So actually, if from the process, right, you need both the IP address in this case, right, network address and the port number, right? So when one process needs to identify the correct process at the destination, you need both. The process needs both the IP address and port number. So actually now you can say that the address of your process is a pair of address, right? A pair is, this pair of address consists of IP address and port number, right? And this we call a socket. If you like network programming, you will hear this term, the socket number. What is the socket number? The socket number actually is a pair of IP address and a port number. So when you do the programming, you are on the process, right? You sit on the process, and the information that your process needs is a socket, right? And also you need a pair of socket because it's a source and a destination, and you also need two-way communication, right? And also if you look at this back, right? Suppose all of this, you see, go to what? IP. Right? Both the TCP and UDP sit on the IP layer. Right? So what it mean? What it mean? You also need the multiplexing and demultiplexing between transport and IP also. Right? If you do the assignment, you have to get the answer for this. But I know that I didn't teach you before. So that's why it's not in your exam. But if you do the assignment, you will learn about it. What is the identifier in the IP that used to identify TCP and UDP? But you learn at this time, you only learn about the IP packet. What protocol field in IP used to identify UDP and TCP? You remember? No. You know, the network engineer must know. It's a protocol field. Right? The protocol field in IP header used to identify that these packets belong to TCP or UDP, and also actually belong to other, like belong to the OSPF or not, or any other protocol that sits on top of the IP. And if you notice in the detail, right, you will see that the protocol field is the identifier for only the destination, not need identifier for source. You know why? This is in your assignment. Why? It's because of your source can have only one. Right? Your source, in this case, the identifier between IP and transport, right? Between the network and transport, your network or IP can be only one, right? Only IP, right? You don't have many here, right? But different from this, you need both the source and destination hot number, because from this to this can be many, and from this to this actually can be many. Like some protocol, right? Some protocol like suppose is the TFTP protocol. It can run over the UDP or run over the UDP. It can be both. Right? So some protocol can run on both the UDP and TCP. Right? So that's why you need both a source port and destination port. But in this case, you only need one field, right? Protocol field, to identify the upper layer. Okay? I just clarify for you that from the IP layer to the upper layer, right? IP layer to the upper layer, you only need one field for identifier. Okay? And if you look at the port, the length, actually this is the address, right? And this is the address space, right? It's another kind of the address, not IP address, it's the port address, right? They have some arrangement also, right? Usually from 0 to 1020T at the beginning of length. Right? This first length we call it a well-known port number, and this well-known port number is usually for server side, and is assigned and controlled by Internet Agency, ICANA. I can't remember what it stands for. You check the website, right? And at the middle length, from here, 1024 to 49151, right? We call it the registered port number. What it means? It means that you ICANA not define, but allow many developers to register. Right? You develop the new protocol, right? You can register, right? And the last length here, right? It's allocated for the dynamic port. This is for client side, right? This is for client side, right? Have no control from ICANA, right? They didn't control, so mostly it's used for client. Right? Why the client can use the dynamic? Why the client can use it? Because you see that you already have the socket, right? Address, right? Equal to IP address plus port number, right? And to identify one connection to the process, to another process, you need a pair of socket address, right? So what it mean a pair of that? It means that you have the IP for this is for the A and this is for set B, IP for host A, right? Pass, suppose this one is the client and the port for A, right? And IP for host B pass port B, right? Actually, one server, right? You can serve to many clients, right? So to assign the port on the client side, right, on the same host, the port number not repeat. Okay. So if this size, this is a socket from client. If this size is on the same host, this one are the same, but these one are different. So totally, absolutely, is different. And finally, is different. If this one, the client side come from different hosts, these paths are different. These paths, you don't care. It can be repeat. Right? Finally, these paths are different. So whatever the server size are the same, you go to the same server, the connection identifier are different. Right? Because a pair is the identifier for a connection. Okay? Who cannot get it? Everyone can get it. Okay? Good. See you in the exam. For the server size, mostly because the server size is a well known, right? Is a well known, so you have to fix it, right? Otherwise, client cannot connect to your server, right? Because if your server also dynamic, who know, right? No one can connect, right? Because I don't know that this web server use which port, and the other server, web server, I don't know what's the port number, right? Actually, almost all the server, web server, use the same port. It's a well-known port. What is the port number? 80. Yeah. That's why we fix the server side port number. But you can change. Actually, in the program, right? You can configure that your server uses different port. But that means this is not well-known server. Right? When you do the browser, right, your user don't know what is your port number. You have to call them. Right? What is your port number? Tell me, and you can connect. Or otherwise you have to scan them. Scan the port number. You can use the program to scan. Right? It basically is an NNAP program. So because the server side, you have to fix the port. Like on the many Unix, most of the Unix like operating system will fix on this file. /etc/service. Right? This is the file configuration to fix the port number for the server side. Right? So when you start the daemon process, right, they will read this. Right? And they get the port number from this. Right? And from this, you can see that TFTP can use the same port number for different protocol, different transport. It not matter, like as I mentioned. Right? So it means that this TFTP protocol can run over the service from the TCP or UDP. Not matter. Okay? But anyway, you get the different service. If they use the UDP, is unreliable transport. Right? If they use the TCP, it's a reliable transport layer. Right? Same, sometimes protocol can have multiple ports. Right? Also FTP also uses 2 ports. Right? Data port and control port. They use 2 ports. Right? For SMMP, they can use many ports. Right? 1 port is different, mostly is a different function. Right? It depends on the design of the protocol. We didn't learn about this. You know that actually we don't have enough time to go to the application layer of the network. Right? If you go to the application layer of the network, you will learn about the HTTP, HTTPS, SSL, right? SMTP, SMTP, a lot of the protocol. And this is the concept that I mentioned you before, the socket. Right? As I mentioned you, the socket, to identify the process. Right? Only the port number is not enough. Right? Because the port is the domain of the port or the scope of the port number is only unique for only one host. Right? It's unique for only one host. Right? So you have to combine between a host address and actually this is a process address, right? Port number. You have to combine both to get a unique port, also unique process on a host. Okay? And this combination we call a socket address. Right? And a pair of the socket address is the ID of the connection. Right? As I mentioned you, right? Because you pick up one pair of this is the connection ID. And this is just only the mechanism, right, of the message, right? Message from the process, right, turn to be the payload in the transport layer, right? And the transport, they have a header that only include include many things. And one of them is a port number, source port and destination port, right? You will learn about the format of the TCP UDP later, right? So now, if based on this logical channel, right? Actually, under this is IP, data link, and physical, but now you don't have to care, right? You can imagine like this data unit, right? The data unit of the transport layer go directly to the other side, the destination, right? And the transport layer just decapsulates, right? This encapsulate size and this decapsulate size and return the payload to the process of the server. You can imagine it. Okay? And also this, I already discussed about you, right? It's the multiplexing and demultiplexing, right? So in this case, you see that this client can have a many process, right? And all of these go to the same transport layer, right? And this transport layer can have a logical connection to the transport layer on this server and also on this server, right? Who separate it? What the address that used to identify that this logical connection for this server or this server? What the address you use? Again, what? What you mean? I ask you that now this client can create a connection to this server and this server also. What the address you use to isolate two server? IP address. When they list this server, the logical connection, right, still can go to this server to the correct process, right? So you have two connections, right, from process number 1, right? Actually, the process of application 1, right, build the message number 1 over by the multiplexing. The packet number 1 go this way, and the packet number 3 go this way, right? And then they go to this transport, and then demultiplex M1 to the process of application 1, and demultiplex M3 to the process of application 3, right? Now, you know that you use an IP address to list this host, this server. And what is the address you use to list the process? What is the address? When you list this, what is the address you use to demultiplex? Very simple. What address? Why? It's very directly, very straightforward. You use the destination port, right? You use the destination port to demultiplex, right? So actually, this one, if you look at the connection between two processes, right? From P1 on client side to P1 on this server side, right? You look at the IP address of this server and port number of this process, right? And on this side, you look at the IP address of client past the port number of process 1, right? So it means that this is a socket on client side, and this is the socket, that is the socket on the server side, and this is the logical connection, right? It's the same. Whenever you go to the same server, right? From same client to the same server, different process, right? You can identify the other connection by the same component, right? IP for client, port for P2, IP for server, and port for P2, right? One pair of socket can identify. And also the same, right? PT go to this, right? Maybe this one is P2, it not matter. You can repeat the number, right? Because it's already on the different host, right? The scope of the port number only unique under a host is enough. Okay? You still can identify logical connection between two processes unique. I'm not sure that you can clarify this. I look at your face and see a lot of doubt. Right. Any question? I have to finish early today. I have an external meeting. And tomorrow, bring your laptop to the class. We will test our simulator again. And let's say that I hope that we can finish in the class. And also, I think a lot of you, not a lot of you, almost all of you, cannot finish the lab. So, I talked to Ukit that if the simulator can work well, you don't have to repair. You don't have to compensate the lab. You do it on the simulator and send to him. Right? It's much easier and better. Right? So everyone can do. Right? And I will show you tomorrow. Right? When you finish your lab, right? You will see the directory and find something that relates to your work. You just zip that directory and send to him. Right? So he can uncompress your zip file, right? And run your simulator, and then he can test your work, your network simulator is work or not. So what does it mean? You have only two marks, two possible marks, 0 and 1. Okay? 0 and 1. If your simulator fail, you get 0 for that lab. If your simulator can run well, you get 1. And not copy. Because I told everyone before, right? In your simulator, they have a random number. If you copy, definitely you get 0. Okay? You understand what I mean, right? If you copy, you definitely get 0. So, I hope all you can do the lab. I didn't mention this before because our restriction is about the simulator. If tomorrow simulator can run well, we can go ahead. So probably, or you don't have to send a lab report. If you can, I will test it before. If the simulator works well and you can send the simulator to Ukrit and he can mark up your lab, right? If everything fine, you don't have to send a lab report. We will change our lab to software lab. Okay? And probably we can have a hand-on exam on the lab because you have all, right? So you can do a hand-on exam on the lab. So I give you everyone the same question, same exam, and you do the same at the same time. If the simulator can work well. Okay? So for or you inform your friend also. Okay? Inform your friend about this. Do you know what I said before? Ask your friend about my announcement, right, in the class. Okay? And inform your friend that who didn't show up today. Okay? Okay? Inform your friend. Okay? We done for today. And how about all your VPN?
So I got the VPN to work after I went to the lab. Apparently Aventail doesn't work with Windows 10.
I cannot get it to work.
Doesn't work with Windows 10.
So there's a different VPN for Windows 10.
Okay. Oh, I know. They have two software.
Yeah.
One version is for Windows 7, and the other version for Windows 10. Yeah, I know. But I don't know where you get it. You still cannot get? Go to see the UKIT.